Okay, well here I'm about to talk to you about section 18.4, which has to do with naming complex ions and compounds that involve transition metal cations and ligands. So a good reference is table 18.2. First I want to talk to you a little bit about the ligands. And so ligands get these names. Iodo is the I minus, chloro is the Cl minus, the chloride ion. When OH minus hydroxide becomes a ligand, we call it the hydroxo ligand. Cyanide ion becomes the cyano ligand, and those are all -1 charges, and you can also get neutrally charged, non-charged ligands. Water, as you know, and the name for water when it's a ligand is aqua, and the name for the NH3 ligand when it's a ligand is amine. How about the cations? Well, here's Fe2+. What you'll see this appear as is its ordinary name, iron, and then Roman numeral 2. That's to indicate the 2. Sometimes you'll see the iron appear as ferrate, and something like that. Cobalt 3+ might appear as cobalt 3, or it might appear as cobaltate 3. Now when they are combined, I have a certain number of ligands attached to each metal, so that might be N, and when there's 2 ligands, we would say have a prefix called di, tri, tetra, penta, hexa. So if we had, say, a hexa aqua, that would mean that there are 6 water ligands attached to a transition metal cation. So I'm going to talk a little bit about problems 33 and 37 in the text. Now I know that in the text the way the problems are pitched at you is that you're given the name and you're asked to produce the formula. The skill that I really want you to get is actually, it's easier, and it goes the other way. That is to say, in the problem you're given a formula and you're supposed to put the name. It's a little bit easier if you start off with the name and then need to produce the formula, which is what I'm going to do right now. So here I'm going to start off with this one, and you kind of start off with the metal name. I see it's a cobalt 3, so I'm going to write CO. There's the cobalt. I see it needs 6 water ligands, so I put those in parentheses, H2O with a subscript 6. Now, most transition metals complexes are charged. That's why we call it complex ions. So what's the charge on this one? Well, the water doesn't have a charge, but the cobalt 3 does have a charge. As we saw, that's the 3+, so I would write a 3+, just like that. So if you want, maybe take a shot at the next one. Okay, and let's see how we can go about that one. I see it's an iron 3. It looks like it has 5 amines on it, 5 NH3s and a single chloro. So I'm going to write the symbol for iron there, and I'm going to follow it with 5 NH3s, NH3 5, followed by a Cl ligand, chloride ligand, putting brackets around to show it's an ion. Now let's see, I know that the iron has a 3+ charge, but the chloro has a -1 charge, so this must have a net of 2+ on it. Yeah? Well, if you want, you can give that next one a try. Okay, so let's see, what do we have? It's a hexacyanoferrate. Well, I know that ferrate, that's another name for iron, so I'm going to put Fe. Hexacyano, let's see, there's the cyano, it's the cyano ligand, Cn with 6 of them because it's hexa. Now I'm going to put brackets around it. The iron has a +2 charge, but each cyanide comes with a -1, so we add all that up. That must mean we have a 4- net charge on that complex ion. Yeah? So the last little bit here is it's when we're actually going to try to name a compound. Now, how is a compound different from a complex ion? Well, you can never buy complex ions. You can't get you can't just get, off the shelf the complex ion. Things have to be electrically, balanced. And in this case, since this is an anion, it means that there must be some cations associated. Now, what those cations are not part of the, they're not ligands. They're just hanging out there to provide electrical balance. And the way that you know that you're dealing with the name of a compound rather than a complex ion is that there are two words. So you notice the second one, hexacyanoferrate 2, that's the same thing, hexacyanoferrate 2. So I know I'm working with the same second, with this complex anion. Now, the potassium, that's obviously going to be there for charge neutrality. Now, I know that potassium likes to make a single plus ion. If I want to have enough potassiums to balance out that 4 minus, then I need to have 4 potassiums, so that's written like this. So what I've written here now is the name of the compound that contains the hexacyanoferrate 2 ion, and is the potassium salt of that. Okay.